Hi, I'm Paul Keoghan from GK Tuition, and in this video I want to talk to you about geometry. Now the question I've chosen to go through here is 2016 Paper 2 Question 4. In the first part of this question, we're asked to prove that the triangle ABD and the triangle DBC are similar. Now you should recognize that similar triangles are triangles where all the angles are the same. And in order to prove the two triangles are similar, you have to prove they have at least two angles in common. We don't actually need to prove that all three are equal. We only need to prove that two sets of angles are equal, because the three angles have to add up to 180 degrees. So if two of them are equal, then the third set of angles has to be equal. Now you should recognize one thing here. I'm told that D is standing on a diameter. Okay, so AC is a diameter. And if you have a point at the edge of a circle standing on a diameter, then that has to be a right angle. So this is straight from one of our corollaries from Junior Cert. But I know because D is standing on the diameter AC, that has to be a 90-degree angle. And you should know that, you should remember that from your geometry from Junior Cert. Now in this question, we don't actually have enough information to directly prove that the triangle ABD and the triangle DBC are similar. We're not going to be able to prove that they have two sets of equal angles. So what we need to do in this case is we're going to prove that the triangle ABD and the big triangle, which is triangle ADC, are similar. So we're going to prove the triangle on the left and the big triangle are similar. And then we're going to prove that the small triangle on the right and the big triangle are similar. If I prove the one on the right and the big one, and then the one on the left and the big one are similar, then clearly all three of the triangles are similar and they all have the same angles. So let's just start that one off. Okay, so I'm going to start off by proving that triangle ABD and the triangle ADC are similar. So usually I think it's a good idea to write it like this. In my head I'm splitting this into two different columns. So whenever I write information about the triangle ABD, I'm going to write it on the left. Whenever I write information about the triangle ADC, I'm going to write it on the right. Now, I need to come up with two sets of angles that are equal. I think straight away you should recognize that both of them have a 90-degree angle. So in the triangle ABD, I'm going to say that the angle ABD, which is this one here, is equal to the angle ADC. Okay? And whenever you write something like that, you have to justify it. So my justification in this case is that they're both 90 degrees. Okay, so clearly they're both 90 degrees. So that's one set of equal angles. The other set of equal angles is the angle at A. Because if you notice the angle at A here, it's in both of my triangles. So if I'm taking the triangle ABD, I can call the angle DAB. Okay, so the angle DAB is equal to the angle DAC. Okay, so because it's actually the same angle in both cases. My justification there is that it's a common angle. Okay, once I have proven they have two sets of equal angles, I can then conclude. So I will conclude by putting my three dots for a triangle to signify therefore the triangle ABD and the triangle ADC are similar. Okay, so that's my first step. Now the second step of this question is going to be pretty much identical to that, except I'm going to prove the small one on the right and the big one are similar. So maybe just try it yourself before you move on and watch the rest of the video. Okay, so if we continue this question on, now I'm trying to prove that the triangle DBC and the triangle DAC are similar. So the one on the right and the big one. Pretty much identical to the previous part. I can say that the angle DBC, which is my right angle on this side, is equal to the angle ADC, which is my right angle standing on the diameter. My justification is that they're both 90 degrees. Then the angle, both of them contain this angle. So I can say that the angle DCB is equal to the angle DCA because it's a common angle. Once I've proven they have two sets of equal angles, I can conclude that the triangle DBC and the triangle DAC are similar. So I've proven the one on the left and the big one are similar, the one on the right and the big one are similar, which means that clearly the one on the left and the one on the right are similar to each other. The triangle DBC and the triangle DAB are similar. So that's the first part of the question. We need to use that in order to answer part 2. Okay, so for A part 2, I'm asked to find y in terms of x. Okay, we've proven that the triangle ABD and the triangle DBC are similar. In similar triangles, all the angles are the same and the sides are proportional to each other. So you'll notice here I've marked in my angles. Okay, so first of all, I've changed the orientation of my triangle so I can compare them. I know that the angle here at B is equal to the angle here at B. They're both 90 degrees. I know the angle at D here is equal to the angle at C, and the angle at A is equal to the angle at D. And based on that, I can tell which sides are proportional to each other. So looking at, I've filled in, I was told AB is X, BD is Y. DB is Y, and BC is 1. Okay, so that's the information I've been given. I know that this side of the big triangle divided by this side of the small triangle will be equal to the base of the big one divided by the base of the small one. So I can just straight away write that in. So I suppose first of all, the first thing you should write is that I know AB divided by DB, the side AB divided by the side DB is equal to the side DB divided by BC. Okay, in other words, the side of the big one over the side of the small one is equal to the base of the big one over the base of the small one, because the sides are proportional to each other. So with that in mind, I can just sub straight in. So let me do this over here. So in this case, AB is X, and so X over Y, so X over Y is equal to the base of the big one over the base of the small one. And the question was to get Y in terms of X, which means I just need to simplify this down to isolate my Y. So in this case, the easiest thing to do is to multiply both sides by Y. If I multiply both sides by Y, my left-hand side just becomes X, my right-hand side becomes Y squared. So at the moment I have X in terms of Y, but I've been asked to get Y in terms of X, which means I need to isolate my Y. Clearly, if I have a Y squared and I want to go to a Y, I need to get the square root. If Y squared equals X, the square root of Y squared is just Y, and the square root of X is, I'll just write it as the square root of X. So Y in terms of X is the square root of X. Okay, so I hope this video made sense. If there's anything you're unsure of, or anything you want me to clarify, just let me know in class during the week and I'll try and explain it differently.